Good morning, students. I hope everyone is doing well. Today I am going to continue the same chapter, lesson elements, compounds and mixture, in which today I am going to discuss the two topics. One is compounds and another is mixtures. First I will explain the compound in details. Before I start this compound, you must be knowing that I have completed in the last session elements in details. Today I am going to continue with the compounds now. Now what is compound? The definition of compound is what? It is a pure substance formed by the chemical combination of two or more elements in a fixed ratio by mass. Means what? It is a good keyword. Okay, you should not forget. And this is another keyword, chemical combination. They are not mixed physically, they are chemically combined. So it is a pure substance, because you know that elements and compounds are part of pure substance formed by the chemical combination of two or more elements in a fixed ratio. Fixed ratio means what? Let us see. H2O is a compound. It is made up of two elements, hydrogen and oxygen. And what is the ratio is there? Because you know that atomic masses of each are, hydrogen is 1 and oxygen is 16. So, and since two hydrogen has been combined here, so 2 is to 16. So you divide the both, you will get 1 is to 8. Okay. So 1 is to 8 by mass they are combined. Mass means atomic masses we are talking about. Okay, so and what is the ratio? Ratio is 2 is to 1 ratio they bear. So in this way the definition comes out of compound. Now in the elements also you have come to know that element is made up of a unit atom. Now when two atoms combine they make a molecule. Now they are no more now atom, it is a molecule. Because more than one atom when come together they are becoming a molecule. This molecule is the smallest unit of a compound. So the smallest unit of a compound is molecule. That means one molecule is a unit of a compound. Properties of molecules. Now suppose H2O is also a molecule of a compound and CO2 is also a compound. Okay, so like this if I write CO2, then it is also one compound, but it is also made up of molecule, it is also made up of molecule. So molecule of water is different from the molecule of carbon dioxide. They are not same, okay, because their properties are totally different from each other. So properties of molecules of one compound are different from that of molecules of other compounds. Okay, now any example you can take of our day-to-day life. Sugar, it is a compound. Chalk, it is also compound. Carbon dioxide, it is also compound. Sand, silicon dioxide, SiO2, it is also a compound. Like this, various compounds of our day-to-day life, also in the lab, we find that they are made up of, they are all compounds. Okay, now compounds unit is molecule. The next we will come to know about their characteristics of compound. Now we will talk about the characteristics of a compound. The first characteristics. Properties of a compound is different from its constituents elements. Let us see some example of this. When hydrogen combines with oxygen, these are two elements. When they combine, they give water. And water is a compound. Its property is totally different from the constituent elements that are hydrogen and oxygen. Next is the compound can be broken into its constituent elements, but by the process that is called chemical combination. That means by chemical process it can be again broken down to their respective elements. That means water is a compound after formation. If you want to turn them back to the respective elements, it can be bring back, but only by chemical process or chemical reaction. Physical process, mixing cannot be done to bring back to their respective constituent elements. Third, they have fixed composition of their own. Fixed composition of their own means what? That means this is the one molecule, this is also one molecule, and this is also one molecule. And in order to make them balance, it becomes 2. When we form a compound by its elements, so what happened? Each elements bear a fixed ratio, fixed composition is there. You cannot change the composition that I need so many elements, so I have to give of my own wish. I cannot do. So they always have a fixed composition of their own. Okay. Now coming to the fourth point, represented by a definite formula or chemical formula or molecular formula. Formula can be named as 3 names are there. Okay, any one name. If you say any compound is always denoted by formula. Children, you have learned in the elements also, elements are always denoted by symbols. Similarly, compound is always denoted by formula. That means this is the formula of a compound. How many molecules are there? If water has no number before it, then it is tend to be 1 molecule of a compound. And since 2 is there, it is a 2 molecule of a compound water. Okay. And the last point, the last characteristic is energy is either absorbed or liberated during the formation of a compound. That means the energy is required to, in this process energy is required. Heat energy is the energy which is often given to the chemical reaction to proceed. So energy is often required, or sometimes energy is liberated as a one of the product in some of the chemical reactions. So energy is either absorbed or liberated. Any one will take place. Both will not take place during the formation of a compound. So these are the basic characteristics of a compound. Now we will see the basic compounds with their formula and what are the constituent elements they are consisting in them. So let us discuss some of them. In your book also it is there. So you can go through the table 3.3 in the page number 30. So students, you will practice from there also, and few I am discussing there. Now let us see the compound table. The table of a compounds, in which I have taken few of the compounds as an example. Rest of the example you can learn from the table 3.3 in page number 32 of your book. So try to learn them, try to remember them nicely along with their formulae. First example, I have taken carbon dioxide. Carbon dioxide is a very well known gas, always present in our air, and we also exhale from our nose. Carbon dioxide contains the elements which are present in them are carbon and oxygen. Now this carbon and oxygen we can easily, and they make a fixed ratio here, CO2. The formula of carbon dioxide is CO2. One thing you will see, if you know the symbols of each element nicely, if you remember them nicely, then it will be very easy to say from the formula only which are the elements present there. Suppose if you know C is carbon and O is oxygen, then you can say these are the only 2 elements present in carbon dioxide. Okay, so similarly with the other compounds also you can learn by seeing the formula only, provided if you remember the symbols of them. Okay, now next is the silica. Silica is the common name is sand. Sand is having the elements in them silicon and oxygen. So formula comes out SiO2. Now coming to the glucose, very well known, all the time we are taking as a good source of carbohydrate. What are the elements present in them? Carbon, hydrogen and oxygen. So the formula comes out C6H12O6. Okay, so from here also 3 elements are clearly visible for us. Next is the baking soda. Baking soda, you must have seen that it has been added to produce puff so that it becomes the cake, biscuits becomes very soft because of the baking soda. Now it contains which are the elements? 4 elements are present. Sodium, hydrogen, carbon and oxygen. So you can see sodium, hydrogen, carbon and oxygen. So from here also you can easily know the formula NaHCO3. What is the chemical name of this? Sodium bicarbonate. Any extra H is present in this is known as the bicarbonate or sodium hydrogen carbonate. Now coming to the next, quicklime. Quicklime is also known as calcium oxide. So what are the element present in quicklime is calcium and oxygen. And what is the formula of this? Calcium oxide CaO. So students, you have seen that few of the elements I have discussed with you, and please go through them from the table which I have given you, that is the table 3.3 from your book, page number 32. Now let us discuss the next topic, that is mixtures. Now what is mixtures? Mixtures are impure substances formed by mixing two or more pure substances, you know who are the pure substances? It can be elements or compounds also. In any proportion means varied proportion, means it can change. If you change the proportion, they are known as any or varied proportion, without undergoing chemical change and retain their individual properties. That means, suppose air is a mixture. Let us take one example. Air is a mixture, and air contains so many gases inside them, but all gases have their individual property. When we want to breathe oxygen, we can easily take oxygen from the air. Green plants need carbon dioxide for photosynthesis. They take only carbon dioxide for photosynthesis. So for example, we can easily take that air is a very good example for mixture, in which it contains several components. All are elements or compounds. So these are all having their individual property also, and these are mixed physically, not chemically, in any ratio. You see, any ratio means what? Suppose in the atmosphere, you will see oxygen level is not the same everywhere. In the plains, we find oxygen in normal level, and when we go to the mountains or we go inside the sea, in the coal mines area also, when we get down, we used to carry oxygen cylinder. Why we used to carry oxygen cylinder? Because there is scarcity of oxygen over there. In the same atmosphere, you find that the level of oxygen, amount of oxygen is not the same. And what is oxygen? Oxygen is one of the component of the air. So we can easily say that they are not undergoing any chemical change and retain their own individual properties. Now coming to the how this mixture is made up of. What are they known as? Who form the mixtures? They are known as components or constituents. You can say components of mixture also, or you can say constituents of mixture also. Both are same. So what are components or constituents of a mixture? They are the substances that form the mixture. Suppose in the making of the air, so many gases which are, some are like, you see, in the air, in the formation of air, you see that hydrogen is also there, oxygen is also there, then nitrogen is also there, carbon dioxide is also there. So these are all what? They are elements and compounds, and these all are known as components of the mixture. Okay. Now we will see now the major types of mixture. The first type of mixture is heterogeneous mixture. Before I start this, students, you must be knowing in the class 6 also, this mixtures, compounds have been taught to you. The general idea you must be knowing about the types of mixture. Then also we are giving a detailed idea of this. So what is heterogeneous mixture? Heterogeneous mixture means where the components are not equally distributed. Okay, not uniformly distributed throughout its volume. Volume means whatever amount you have taken. And that's why what happened, you can easily see them. Suppose sand and salt, you can easily see them. Where is the sand, where is the salt, and the distribution is totally unequal. Because if you take a handful of sand, that mixture, you don't have the guarantee that you have got equal amount of sand and salt with you. So it depends upon, because the distribution is totally unequal. Similarly, in the liquid state also, you can take oil and water also as an example, which is coming under the heterogeneous mixture. The next type of mixture is homogeneous mixture. Now homogeneous mixture is just the opposite what we have done the heterogeneous mixture. In homogeneous mixture, the constituents or the components are uniformly distributed throughout its volume. That means if you take water and add some salt to it, and after stirring, salt will be equally distributed throughout the water. That's why you get the same taste in the water, whichever part of the water you drink. So distributed throughout its volume and cannot be seen separately. Since it mixes homogeneously, you are unable to see where the salt is there in the water, because it's mixed thoroughly inside it. So similarly, water and alcohol also, water and acid also, if we mix together, we are unable to find we are unable to see them separately. So Similarly, in the milk, tap water, they look like compound, but actually they are also mixture because they contains dissolved gases and dissolved minerals in them. What about milk? It contains water, it contains some other proteins and all in the dissolved way. Look like compound, but actually they are what? They are homogeneous mixture. Similarly, orange juice, all the fruit juices, you can say, like ink also, honey also. Okay, so medicine, some tonic, cough syrup and medicine also, you will see they also look like compound, but actually they are all homogeneous mixture. So I have told you many examples of homogeneous mixture. In your book also it is also given there. So please try to learn the different types of mixture from the book. Now coming to the next topic, that is the characteristics of mixture. Before I start the characteristics of mixture, in the definition of mixture also I have told few of the characteristics from here. That is only the characteristics. So first characteristics is what? Components are held together by physical means or force. That means they are physically mixed together. They are not chemically combined. Okay? With the help of chemical reaction, they are not combined. They are held together or mixed together by physical means or physical force. Next is they retain their individual property. I have told you already earlier that retain their individual property. I have given the example air. It contains several gases, but then also oxygen has its own identity, carbon dioxide has its own identity. That's why we respire only oxygen for respiration, carbon dioxide for photosynthesis. That means they don't lose their identity in the air. Okay. Third, they are mixed in varied ratio. Their ratio is not same everywhere, because in a compound you will see they are combined in a fixed ratio. Here it is varied ratio. Varied means any ratio. Suppose in a glass of water, if you add 1 spoon sugar, then also it is a sugar solution. If you add 3 spoon sugar, then also it is a sugar solution. But the difference is what? In its taste as well as in its content. Okay, how much amount you have. But the 2 glasses of sugar solution are different from each other in their components. Next is the can be separated by physical method. I have told you that they are held by physical means, so they can be separated also. Suppose the air contains nitrogen, oxygen, we can easily separate out the oxygen from the air by the fractional distillation method is there. That is also a physical method. Next is the can be heterogeneous, can be homogeneous. Obviously mixtures are of 2 types, so it can be homogeneous, can be heterogeneous also. But in case of compound, we have seen always homogeneous. The next is the no fixed melting point or boiling point. In short, I have written, children, that means compounds are made up of elements and all. So element, compound, they are all what? They are all pure substance. So they have a fixed melting and boiling point. But mixture is an impure substance, so it has no melting and boiling point is not fixed. That's why you see that when you add more salt to the water, the boiling point will be increasing. And if you add less salt to the water, then boiling point will be decreasing. If the water is totally pure, no impurity is there, then the water will boil at exact 100 degrees centigrade. Now we come to the last point of this. No energy exchange is involved during the formation of a mixture. So since mixture is in the mixing of the mixtures components, only they are physically mixing, so there is no energy exchanges going on for giving energy absorbing or energy liberation is taking place in, it doesn't take place in the formation of mixture. So students, we have learned the characteristics of the mixture and the types of mixture. The next topic is the how mixture and compounds are different from each other. It has been given in your book, the page number 36, the table 3.4. You please learn from there because they contain only the characteristics which I have explained. I have explained the characteristics of mixture also, explained the characteristics of compound also. So these 2 characteristics are totally different from each other, which have been given in point wise in your table. So you try to remember 4 points minimum. Okay. Now we will discuss the formation and types of mixtures. How mixtures are formed on the basis of their properties and uses, because mixtures can be formed by the different forms of matter, solid, liquid or gases in varied proportion. But the basis is what? On the basis of their form, properties and uses. And the types of mixture. Types of mixture we have learned, the homogeneous and heterogeneous, based on their physical states of their components. On the what are the physical state of the components are there, on the basis of that we will see that what are the different types of mixtures can be categorized. This table which I have made, students, this table is given in your book also in the page number 36. So please go through them nicely. Now the first state is solid-solid mixture. Solid-solid mixture can be heterogeneous, can be homogeneous. So in heterogeneous you can take two solids, sand and salt also you can take, stone and sand also you can take, rice and stone also you can take. Both should be solid and it should be heterogeneous. What about the solid-solid homogeneous? Any alloy you can take. You know alloy is the best example of homogeneous mixture in solid condition. But they need to be molten, and then when they form the mixture they form a homogeneous mixture. After that they are again solidified. Then next is the solid liquid mixture. It will be again heterogeneous, homogeneous. In heterogeneous, sand and water, you can take sand and water is the best example, where you can take chalk powder and water. It is also coming under the category of solid, liquid, heterogeneous. Now homogeneous, sugar solution, salt solution, all these things are coming under the homogeneous mixture. Now coming to liquid mixture. Liquid mixture, heterogeneous, all heterogeneous you can take. Oil in water, petrol in water, diesel in water. Next is the homogeneous mixture, in which alcohol and water, acetone and water, all these are coming, in which they uniformly distributed throughout its volume. Now coming to gas liquid mixture. Gas liquid mixture is not liquid. The gas is always homogeneously mixing into the liquid, but in normal condition they mix very little. Under high pressure they mix in a required amount. So cold drinks are the best example, in which carbon dioxide gas is mixed into them, and that's why that fizz sound comes when you open the lid of the cold drink bottle. Now coming to gas mixture, it is also homogeneous mixture. I have told you air is an example of homogeneous mixture. So pure air. Okay. Now coming to the solid gas mixture. Solid gas mixture is a heterogeneous mixture, because solid is what? Any dust particle mix into the air, they can be easily find out. Or smoke also you can take. That smoke contains what? Black carbon soot particles. When they mix into the air, they form the smoke. So this smoke is also an example of a heterogeneous mixture. So students, you have learned today about the compounds and the types of mixture, characteristics of mixture and the formation of mixture in this class. So please go through the book nicely and be healthy. Have a good time. Thank you.